Today we will be learning about the commutative and associative properties of addition. Now these seem like really big words that we've never heard before, but really they're simple things that we use every day in math. Let's do some examples together and see how these big words play into what we do every day. Let's take this simple example that we all know how to do, 2 plus 2. Let's start by taking 2 squares Okay, so we have 1 square, we have 2 squares, and we're going to add that to another 2 squares. My squares are terrible, but this is just because I'm hand drawing. When we add 1 square, we add 1 square plus another square, we get 2 squares. And when we add the other 2 squares, we get another 2 squares. So we have 1, 2, 3, 4 squares total, which gives us 4 as our grand total. So we all know how to do an example like that. Let's move on to something a little bit trickier. Something like 3 plus 4. Again, let's take our square idea and draw this out to better understand. We have 1 square, 2 squares, 3 squares, and we're adding that to another 4 squares. 1, 2, 3, and 4. When we add all of these together, we are going to get 1, 2, 3 plus 1, 2, 3, 4. That's going to give us how many? 7. 7 squares total. Now let's try switching the order of our numbers and see what we get in that situation. So we are going to take 4 plus 3. We're going to figure that out. Do we think our answer will be any different if we change it like this? So we're going to take 1, 2, 3, 4 squares. This time we're going to add that to 3 squares. Are we going to get the same answer? Let's take a look and see. If we take 1, 2, 3, 4 plus 1, 2, 3, we get 1, 2, 3, 4, 5, 6, 7. Again, we are going to get 7 as our answer. So just because we changed the order doesn't mean that these are any different. Let's try something a little bit different. What about if we use this same idea with subtraction? Do you guys think it would be the same answer? Let's try a subtraction problem that we all know to begin with. Okay. So we're going to take 2 minus 1. Now if we do 2 squares again, minus that 1 square. So we begin with 2, these 2 right here. We're going to take one of them away. So we are left with 1 square. Now let's change the order. Let's do 1 minus 2. That gets a little bit tricky. we have 1 square, one tiny square, minus 2 squares. So if I have 1 square, I need to get rid of 2 squares. I don't have 2 squares. So we cannot get the same answer with that problem. These two are not the same. So our commutative property of addition only applies to addition, not subtraction. You can only change the order when we are adding two numbers. Now let's look at the associative property of addition. This one is a little bit more complicated, but really just the same thing that we've been learning with addition, just adding a little bit more to it. So let's take, for example, the problem 2 plus 1, plus, this is a plus, 1 plus 3. What do we get here? Well, again, let's take our box scenario. They don't always have to be boxes, just so you know. This is just what I'm using for this specific example. Plus 3 more squares. Alright, guys, let's add these up. So we are going to have 1, 2, 3, 4, 5, 6. Alright, so we are going to get 6 as our answer. Now let's try adding just our 2 and our 1 together first, and then adding our 3, and see what happens then. So we are going to take 2 plus 1. Alright, so again, we're going to take our boxes and add another one to it. We are going to get 1, 2, 3. Alright, so this equals 3. Now, we are going to take this 3 from up here. We are going to add it because we're not done with our problem yet. We still have to add 3 again. So we are going to take 1, 2, 3 plus 1, 2, 3, and we are going to get very similar answer. 1, 2, 3, 4, 5, 6 boxes again. So our answers again are the same, even if we choose to add the first 2 and then bring the third one down, or if we add all of them together at one time. This makes it a little bit easier, especially with bigger numbers as we move farther on, to add maybe the first 2 and then add that last one. Or we could even add 1 plus 3, and then we could add the 2 later. We could do this in any order, and this all goes back to what we just learned about the commutative property, that it doesn't matter what order you're working with when it's addition. So what did we learn from this? It's all very simple stuff that we've learned. These words seem really, really big and really scary at first, but really it's stuff that we're going to be using every day and stuff that we can use to make our lives easier every day when we do addition.